Okay, number 8. We have a linear function given and we want to complete parts A through D. Okay, so here on the left, we first want to identify the slope. So of this function, it's already in slope-intercept form. So the slope is in front of x, so our slope is given by 1/6. All right, so the y-intercept, again, this is in slope-intercept form, so it's giving us the slope and the y-intercept. It says type an integer or fraction, so they do not want the ordered pair, just the -6. Okay, so now part B, we're going to use the slope and y-intercept to graph the function. Okay, so first we click this graphing tool. We have to indicate that we're given a line. That's what we're going to be graphing. We're going to go down to the y-intercept first. So we're going to go start at 0, 0, and we're going to go down to -6. And then you click, that makes the first point. And then from there, we're going to use our slope. So rise over run. The top number tells us how much to go up. So we go up 1 unit, and then we go right 6 units. Is that right? Up 1, right 6. There we go. Okay, so once you do that, we have it graphed, and then we click save. I didn't see anything though. There we go. The line is there. It's hard to see. The screen is kind of expanded. Okay, so C wants to find the average rate of change. All right, when you have a linear function, average rate of change is just dealing with the slope. It's another name for slope. So when they ask average rate of change, they're just asking for the slope. So again, 1/6. And then D, we want to determine whether the linear function is increasing, decreasing, or constant. Okay, so the way you read a graph is the same way we would read the statement. We start on the left and we go to the right. So as I trace this line left to right, okay, it is going in the upward direction, indicating that it is increasing. And I think that's all parts. All right, number 9, it says, I guess it's kind of cut off. The information, I can't see what's going on here. Okay, it says information is given about the polynomial f of x, whose coefficients are real numbers. We want to find the remaining zeros of f. So what you need to know here, we have degree 5, so that means we have 5 zeros. So some graph crosses the x-axis 5 times. We're given that -9 is one of them, so it's like x equals these numbers. X equals -9, x equals I, and x equals -5I. So I have 3 of them, I'm missing 2. All right, what you need to understand is if you have imaginary numbers, the only way you can get imaginary number if you do the square root, and every time, always the case, you're going to have a positive or negative. So whenever I see an imaginary number, whatever I see, I also have to have the opposite sign. So if this is negative, part of what I'm missing would be +5I. And then I have a positive I, so I'm also missing -I. Okay. So we need 5I and -I. Those will be our missing zeros.